July 27, 1944, 08:15 hours, near Rzhev, Soviet Union. The improvised armored vehicle that Soviet soldiers had mockingly dubbed Dmitri's coffin rumbled toward German positions with a sound like industrial machinery approaching its breaking point. The engine, a tractor motor designed for plowing fields at 5 miles per hour, now strained to push 32 tons of welded steel plate, salvaged tank parts, and desperate innovation across cratered battlefield at 7 miles per hour maximum speed. Inside what barely qualified as a fighting compartment, Senior Sergeant Dmitry Pavlovich Sokolov gripped the controls he'd fabricated from truck steering components and agricultural machinery parts. Through a vision slit cut into quarter-inch boilerplate, he could see what had made his company commander authorize this desperate assault. 4 German Panzer tanks, hull down behind earthen berms, dominating the approach to a critical bridge that Soviet forces needed to advance their offensive. The conventional Soviet tanks, T-34s and KV-1s, that should have handled this assault were burning wrecks scattered across the killing ground. German 88mm anti-tank guns had destroyed them in the first 15 minutes of the attack. Now, with the offensive stalling and German reinforcements approaching, the battalion commander had made an impossible decision: send forward the ridiculous improvised vehicle that mechanics had been mocking for 3 weeks. Let the crazy tractor mechanic try what proper tanks couldn't achieve. Sokolov's creation was absurd by any conventional standard. The base was an STZ-5 agricultural tractor designed for collective farm work, with armor plate welded across every surface. The armor, salvaged from destroyed Soviet tanks, German vehicles, and even an armored train that had been blown apart nearby, varied from quarter-inch mild steel to 3-inch tank plate. Nothing matched. Nothing fit properly. The entire vehicle looked like child sculpture made from scrap metal, but Sokolov, who'd grown up on a collective farm and spent 10 years as agricultural machinery mechanic before the war, understood something that military engineers hadn't considered. You didn't need sophisticated engineering if you had enough steel in the right places. The front glacis facing enemy fire was 3 inches of salvaged tank armor angled at 45 degrees. The sides were 2-inch plate from destroyed German vehicles. The rear was quarter-inch steel sufficient to stop shell fragments, but not direct hits. The armament was equally improvised. The main weapon was a 76mm gun salvaged from a destroyed T-34, mounted in a crude turret welded together from boilerplate. The gun's recoil mechanism was damaged, so Sokolov had designed a hydraulic shock absorber system using truck suspension parts and tractor hydraulics. It worked, sort of, absorbing enough recoil to prevent the improvised mount from tearing itself apart. At 08:17 hours, the lead German Panzer spotted Sokolov's vehicle and fired. The high-velocity round struck the front glacis at a range of approximately 600 yards. The impact sounded like a giant hammer striking an anvil. The 3-inch armor plate, angled and work-hardened through crude heat treatment, deflected the round. The interior filled with the smell of burned metal and the ringing echo of steel striking steel. Sokolov traversed his improvised turret using a manual hand crank salvaged from artillery piece. The mechanism was slow, requiring 20 seconds for 45-degree traverse, but it worked. Through his crude gun sight, fabricated from truck mirrors and welding glass, he aligned the 76mm gun on the lead Panzer. The gun fired. The improvised recoil system absorbed the shock. The shell, hand-loaded by his gunner, Corporal Ivan Petrov, was armor-piercing round salvaged from ammunition stores. At 600 yards, it struck the German Panzer's turret ring, the junction between turret and hull that represented structural weakness on all tank designs. The Panzer's turret jammed. Smoke erupted from hatches. The crew began bailing out. 1 kill. The other 3 German Panzers shifted fire to this new threat. Shells struck Sokolov's improvised vehicle from multiple directions. Most deflected off the thick front armor or glanced off angled sides. One penetrated the thinner rear armor, but failed to reach the crew compartment. The vehicle, designed with redundant compartmentalization, absorbed damage that would have disabled conventional tank. Sokolov continued advancing. The tractor engine, governed for low-speed, high-torque operation, couldn't be rushed. 7 miles per hour was maximum. But the vehicle kept moving. At 500 yards, Sokolov fired again. The second Panzer took hit to its track and road wheels, immobilizing it. The crew abandoned the vehicle rather than face continued fire from an opponent they couldn't effectively damage. At 400 yards, the third Panzer scored direct hit on Sokolov's improvised turret. The shell penetrated the crude boilerplate armor, killing Corporal Petrov instantly and wounding Sokolov's loader, Private Alexei Volkov. But the vehicle's engine and drivetrain remained functional. The basic design, separating crew compartment from engine with additional armor plate, had saved Sokolov's life. With his gunner dead and loader wounded, Sokolov had to load and fire the main gun himself while simultaneously operating the vehicle. The procedure was nearly impossible, but desperation creates capability. At 350 yards, operating alone in the shattered turret, Sokolov loaded, aimed, and fired one more time. The shell struck the third Panzer's hull, penetrating the side armor and igniting ammunition. The internal explosion blew the turret completely off the hull. The catastrophic kill sent debris 200 feet into the air. The 4th Panzer, having witnessed 3 companions destroyed or disabled by what appeared to be mobile scrap heap, withdrew rather than continue engagement. The German tank reversed behind cover, then retreated towards secondary defensive positions. The improvised vehicle had achieved what conventional forces couldn't. The bridge approach was clear. Sokolov's coffin, trailing smoke, leaking various fluids, and barely functional, limped back to Soviet lines at 3 miles per hour. Total time in combat, 19 minutes. Total Panzers destroyed. 2 confirmed kills, 1 mobility kill, 1 tactical kill through forced withdrawal. Total crew casualties, 1 dead, 1 wounded. Total ammunition expended. 8 shells, 5 of which hit targets. This was the vindication that would transform mockery into legend, that would prove desperate innovation could overcome sophisticated engineering, that would demonstrate why sometimes the best weapon isn't the most advanced one, but the one that refuses to stop fighting. The homemade tank built by a tractor mechanic had achieved what purpose-built military vehicles couldn't. The journey to that battlefield began 29 years earlier in a small village near Tula, south of Moscow. Dmitry Sokolov was born in 1915 to a family of agricultural workers who operated machinery on a collective farm. His father, Pavel Sokolov, was one of the first collective farm tractor drivers, operating Soviet-built STZ tractors that mechanized agriculture in the 1920s. Growing up around heavy machinery meant Dmitry understood mechanical systems from childhood. By age 10, he could operate tractors. By 15, he was performing field repairs that stumped older mechanics. By 20, he was senior mechanic at the collective farm, responsible for maintaining equipment that the entire harvest depended upon. This background created practical mechanical aptitude that formal engineering education couldn't replicate. Sokolov understood stress, torque, improvisation, and the fundamental principle that machinery didn't need to be elegant if it worked. Collective farm equipment operated under harsh conditions with minimal maintenance. Making things work with whatever materials were available was core competency. Sokolov was drafted into the Red Army in June 1941, days after Germany invaded. His mechanical background made him valuable for motor transport companies. But the desperate manpower situation meant all able-bodied men served as infantry first, specialists second. He was assigned to Rifle Regiment as enlisted soldier, with secondary duty maintaining company vehicles. The catastrophic first months of Operation Barbarossa, where German forces destroyed entire Soviet armies, taught brutal lessons. Soviet tanks, while numerous, were poorly maintained, inadequately supplied with fuel and ammunition, and often abandoned by crews who lacked training. Sokolov witnessed dozens of functional tanks left behind simply because crews didn't know how to perform basic repairs. By September 1941, Sokolov's unit had been pushed back hundreds of miles. The regiment was down to 30% strength. Equipment losses exceeded 90%. But Sokolov had kept several vehicles running through improvised repairs using salvaged parts from destroyed equipment. His company commander, recognizing this talent, formally assigned him to maintenance duties. Winter 1941 through 42 brought Soviet counteroffensive around Moscow. Sokolov's maintenance skills became increasingly valuable as winter conditions destroyed vehicles faster than combat. Tanks broke down from cold. Trucks wouldn't start. Artillery tractors seized. But Sokolov kept equipment functional through improvisation that would have violated every technical manual if manuals had still existed. One incident from January 1942 established his reputation. A T-34 tank had thrown a track during combat. Standard procedure was to abandon the vehicle since repairing track in combat conditions was deemed impossible. But Sokolov, using a wrecked German half-track's winch system and improvised tools, managed to remount the track in 4 hours under German artillery fire. The repaired tank returned to combat and later destroyed 3 German vehicles. But this experience also taught Sokolov a frustrating lesson. Soviet armor, while adequate when functional, had critical vulnerabilities. T-34s and KV tanks could be destroyed by German anti-tank guns. Crews were poorly trained, maintenance was inadequate, ammunition supply was inconsistent. The sophisticated vehicles that should have dominated battlefields were failing due to systemic issues that no amount of mechanical skill could overcome. By summer 1942, Sokolov had been promoted to senior sergeant and assigned to Tank Maintenance Battalion, supporting armored forces near Rzhev. This position gave him access to destroyed vehicles, salvaged parts, and workshop facilities. He also gained first-hand observation of why Soviet tanks were failing against German defenders. The problem wasn't capability. A well-maintained T-34 with trained crew and adequate ammunition could defeat German armor. But these conditions rarely existed simultaneously. Instead, Soviet attacks threw inadequately prepared tanks against prepared German positions, suffering catastrophic losses for minimal gains. Sokolov began questioning whether the approach was wrong. Why send sophisticated tanks on suicide missions? Why not create simple, heavily armored vehicles specifically designed for breakthrough operations? Vehicles that couldn't be disabled by single hits, that could absorb damage and continue fighting, that crews could operate with minimal training. The concept violated Soviet military doctrine. Tanks were offensive weapons requiring speed and maneuverability. Building slow, heavily armored vehicles was backwards thinking. But Sokolov, trained in agricultural machinery rather than military doctrine, saw opportunity. Agricultural tractors were designed for reliability under harsh conditions with minimal maintenance. If you added armor and weapons to tractor chassis, you'd create simple breakthrough vehicle that could survive what tanks couldn't. In March 1943, Sokolov requested permission from his battalion commander, Major Viktor Romanenko, to experiment with improvised armored vehicle. Romanenko, skeptical but willing to consider anything that might reduce casualties, authorized use of damaged equipment and scrap materials. "Build your tractor tank," Romanenko said. "But it comes from maintenance stocks, not combat allocations, and if it doesn't work, you're back to regular maintenance duties." Sokolov began with STZ-5 agricultural tractor designed for heavy plowing that had been abandoned at collective farm near the front lines. The tractor's engine produced only 55 horsepower, but delivered tremendous torque at low speeds. Perfect for moving heavy loads, slowly, exactly what armored vehicle needed. The armor came from multiple sources. Destroyed Soviet tanks provided thick plate for front glacis. German vehicles yielded side armor. An armored train, destroyed by German aircraft, contributed boilerplate for the turret. Nothing matched in thickness, composition, or origin. But Sokolov wasn't building showpiece. He was building functional armor that would stop shells. The welding was crude. Soviet maintenance battalions lacked sophisticated equipment. Sokolov used stick welding with inconsistent electrodes on dissimilar metals. The welds were ugly but functional. He developed technique of multi-pass welding with slag removal between passes that created joints stronger than the base metal. The turret presented the most complex challenge. Tank turrets require precision manufacturing for smooth traverse and elevation. Sokolov had scrap metal and basic tools. His solution was crude but effective. A fixed lower ring welded to the hull, a rotating upper ring mounted on ball bearings salvaged from destroyed trucks, and a manual hand-crank traverse mechanism from artillery piece. The system was slow but functional. The 76mm gun was salvaged from T-34 destroyed by mine. The barrel was functional, but the recoil mechanism was damaged. Tank guns require sophisticated recoil systems to absorb firing shock. Without proper recoil system, the gun would tear itself and its mount apart after a few shots. Sokolov designed improvised recoil system using hydraulic cylinders from tractor steering systems, springs from truck suspensions, and fluid-filled dampers he fabricated from pipe and seals. The system was tested by firing the gun while the mount was secured to heavy timber framework. After 3 tests and 2 redesigns, the system absorbed enough recoil to be functional. By May 1943, Sokolov's improvised vehicle was complete. The appearance was absurd. Mismatched armor plates welded at odd angles, crude turret that looked like industrial boiler, exposed track and suspension from agricultural tractor. The entire vehicle appeared to be mobile junkyard rather than combat vehicle. The mockery was immediate and near universal. Fellow mechanics called it Dimitri's coffin and predicted it would kill its crew before engaging any enemy. Tankers dismissed it as tractor, with delusions of grandeur. Officers viewed it as a waste of materials that should have been used for proper repairs. Even Major Romanenko, who'd authorized the project, expressed doubts about its combat value. The test came in June 1943 during German offensive operations near Kursk. Soviet forces were conducting defensive operations, and every available vehicle was needed. Romanenko, desperate for any combat-capable platform, authorized Sokolov's improvised vehicle for combat trial. The mission was simple: provide fire support for infantry defending against German tank infantry assault. Sokolov's vehicle, with a crew of 4, including himself as commander, driver, gunner, and loader, moved into prepared position overlooking likely German approach route. The first engagement lasted 7 minutes. 3 German Panzer III tanks appeared at approximately 800 yards. Sokolov's improvised vehicle fired 6 times, scoring 2 hits and 1 mobility kill. More importantly, the vehicle absorbed 5 return hits without penetration. The thick front armor, despite crude welding and mismatched plates, deflected shells that would have destroyed conventional vehicles. But the vehicle also revealed weaknesses. The slow traverse mechanism made tracking moving targets nearly impossible. The crude sights prevented accurate fire beyond 600 yards. The engine overheated after 40 minutes of operation. The ammunition storage, improvised from wooden crates, proved vulnerable to fire. Sokolov spent July and August 1943 refining the design based on combat experience. He improved the traverse mechanism using gearing from destroyed tank. He fabricated better sights using optics salvaged from German vehicles. He installed additional cooling for the engine. He lined ammunition storage with fire-resistant material. By September 1943, the mockery had diminished. The vehicle had survived 3 engagements without catastrophic damage. It had destroyed or disabled 8 German armored vehicles. While it would never win aesthetic contests, it worked. The function mattered more than form. If you're fascinated by the improvised weapons and desperate innovations that turned the tide in history's bloodiest conflict, make sure to subscribe to our channel and hit the notification bell. We bring you the untold stories of soldiers who achieved extraordinary results through ingenuity under impossible conditions. Don't miss our upcoming videos on the weapons that shouldn't have worked but changed everything. October through December 1943 brought repeated combat employment. Sokolov's vehicle participated in 7 separate engagements, achieving mixed results. The heavy armor prevented penetration in most cases, but the slow speed made repositioning difficult. The crude mechanical systems required constant maintenance. Crew losses forced repeated training of replacements. By January 1944, Sokolov had trained 3 separate crews on operating the improvised vehicle. The first crew was killed by artillery strike. The second crew was reassigned when the vehicle was down for repairs. The third crew, including Corporal Ivan Petrov as gunner and Private Alexei Volkov as loader, developed proficiency with the crude systems. The vehicle's reputation evolved from mockery to grudging respect. It wasn't elegant. It violated every principle of proper tank design. But it survived when conventional tanks didn't. The thick crude armor absorbed damage through brute force rather than sophisticated engineering. Sometimes simple was better. The July 1944 engagement that opened this narrative represented the vehicle's ultimate validation. The mission seemed impossible. 4 German Panzers in prepared positions had destroyed every Soviet tank that attempted the assault. Infantry attacks had failed with heavy casualties. The bridge approach represented critical objective that higher headquarters demanded be taken regardless of cost. Major Romanenko called Sokolov to command post. "Your coffin is the only armor we have left that's functional," Romanenko said bluntly. "I need you to go after those Panzers. Can your vehicle do it?" Sokolov studied the tactical map. The approach offered no concealment. The Germans would see him coming from 1,000 yards out. He'd be under fire for at least 5 minutes before reaching effective range. The Panzers were hull down behind earthworks, presenting minimal target profile. Everything about the tactical situation favored the Germans. But Sokolov understood something that tactical analysis didn't capture. His vehicle's fundamental design made it more survivable than conventional tanks in this specific scenario. The thick front armor could absorb multiple hits. The slow speed actually helped, presenting smaller target and allowing more precise shot placement. The crude mechanical systems had fewer failure points than sophisticated tanks. "Sir, we can try," Sokolov replied, "but I need smoke support to cover the approach and freedom to maneuver as I see fit." Romanenko agreed. Within 30 minutes, Sokolov and his crew were moving toward the German positions. The engagement unfolded as described earlier. What the summary didn't capture was the psychological dimension. Inside the improvised vehicle, Sokolov and his crew experienced terror that sophisticated vehicles' crews never faced. They knew their vehicle looked ridiculous. They knew conventional wisdom said it couldn't succeed. They knew every other Soviet tank had been destroyed attempting this assault. But they also knew the vehicle had protected them before. The crude armor, for all its aesthetic deficiency, had stopped shells. The improvised systems, despite their crudeness, had worked. Sometimes the best defense against fear is experience that things have worked before. At 0823, with 2 Panzers destroyed and 1 withdrawing, Sokolov's vehicle represented the only functional Soviet armor on that battlefield. The conventional tanks that should have succeeded had failed. The improvised vehicle that everyone predicted would fail had succeeded. The mathematics of survival had been rewritten by welded scrap and desperate innovation. The casualties brought sobering reality to the victory. Corporal Petrov's death was particularly tragic. He'd been one of the few crew members who truly understood and believed in Sokolov's vision. His death in the moment of vindication seemed cruelly ironic. Private Volkov's wounds would prevent him from returning to combat. But the tactical success was undeniable. The bridge approach was secured. Soviet forces advanced. German defensive positions were compromised. Higher headquarters filed reports documenting that improvised vehicle had achieved what conventional armor couldn't. The after-action assessment by Soviet Armor Command analyzed the engagement with clinical precision. Subject vehicle, improvised armored platform based on agricultural tractor chassis, engaged 4 German Panzer IV tanks in prepared defensive positions. Results: 2 enemy tanks destroyed, 1 mobility kill, 1 tactical withdrawal. Friendly casualties: 1 killed, 1 wounded. Vehicle damage: moderate, repairable in field conditions. Comparative analysis: previous assault by 6 T-34 tanks resulted in complete loss of attacking force with 0 enemy casualties. Improvised vehicle achieved mission success at lower cost than conventional armor. While specific circumstances of this engagement favor heavy frontal armor over mobility, results suggest value in purpose-built breakthrough vehicles accepting reduced speed for increased survivability. Recommendation: document vehicles' construction methodology for potential replication in similar tactical situations. Note that vehicles' effectiveness is situation-dependent and should not be considered universal tank replacement. This measured assessment captured the paradox of Sokolov's achievement. His improvised vehicle worked brilliantly in specific tactical situations, but couldn't replace conventional tanks in general warfare. It was solution to particular problem, not universal answer. But recognizing when specific solutions outperform general-purpose systems represented important insight. The July 1944 success brought unexpected consequences. Higher headquarters ordered Sokolov to construct additional improvised vehicles using similar methodology, but Sokolov resisted. The vehicle worked because it was carefully designed for specific purpose, using available materials that happened to be appropriate. Mass production would require standardization that would eliminate the custom adaptation that made it effective. Instead, Sokolov trained mechanics on the principles underlying his approach: understand the tactical requirements, assess available materials, design for survivability in expected threat environment, accept crude execution if functional performance is adequate, build, test, modify based on results. These principles could be applied to various situations, but required intelligence and adaptation rather than blind replication. By October 1944, several Soviet maintenance battalions had constructed improvised armored vehicles using Sokolov's general approach, but customized for their specific materials and tactical requirements. Results varied. Some vehicles worked well, others failed catastrophically. The difference was whether builders understood principles or just copied appearance. Sokolov's original vehicle continued combat operations through fall 1944. It participated in 12 additional engagements, achieving 7 confirmed kills and numerous assists. But combat damage, inadequate maintenance due to tempo of operations, and simple wear finally rendered it non-functional in December 1944. By that time, Sokolov had been promoted to junior lieutenant and assigned to Tank Training Command to teach improvised vehicle construction and modification. His combat experience, combined with practical mechanical knowledge, made him valuable instructor for mechanics who needed to maintain equipment under impossible conditions. Before we continue with the post-war legacy and lasting impact of this remarkable story, I want to ask you to take just 2 seconds to subscribe to our channel if you haven't already. These deep dives into the improvised innovations that changed military history take enormous research effort. Your subscription helps us continue bringing these forgotten stories of ingenuity to light. Hit that subscribe button and the notification bell. The war ended in May 1945 with Sokolov serving as maintenance officer at tank training facility near Moscow. He'd survived 4 years of brutal warfare, created a weapon that should have been impossible, and trained hundreds of mechanics in improvised problem-solving. But his most significant contribution wasn't the specific vehicle he'd built. It was demonstrating that sometimes unconventional solutions outperform conventional ones. Post-war Soviet armor development was influenced by lessons from Sokolov's improvised vehicles and similar field innovations. The IS-series heavy tanks incorporated aspects of the breakthrough vehicle concept, accepting reduced speed for heavier armor and larger guns. The focus shifted from light, fast tanks toward heavily armored platforms designed to survive while accomplishing specific missions. Sokolov remained in military service until 1953, retiring as captain. He returned to agricultural machinery work, applying his skills to peacetime equipment. He rarely discussed his wartime service, viewing it as doing what circumstances demanded rather than achieving anything extraordinary. In a 1967 interview conducted for Military Historical Archives, Sokolov reflected on his improvised vehicle and the mockery it had initially received. People laughed at it because it didn't look like a tank, he said. But I wasn't building a tank. I was building armored platform that could survive long enough to complete mission. Appearance doesn't matter if function is adequate. The vehicle did what it needed to do. That's the only measure that counts. The interviewer asked about the 4 Panzers destroyed in July 1944. Sokolov's response revealed his perspective. We destroyed 4 German tanks, but Ivan Petrov died doing it. Was the trade-off worth it? From military perspective, certainly. 4 enemy tanks eliminated at cost of 1 crew member is excellent exchange ratio. From human perspective, I'm not as certain. Ivan believed in what we were doing. He died succeeding. Perhaps that's the best any soldier can hope for. This moral complexity, acknowledging both tactical success and human cost, characterized Sokolov's entire relationship with his wartime achievements. He'd created an effective weapon through desperation and ingenuity. But effectiveness in war meant killing and dying, outcomes that carried permanent weight regardless of military necessity. The physical vehicle that destroyed 4 Panzers in July 1944 was scrapped in 1945. Maintenance records indicate it was salvaged for parts after battle damage rendered it uneconomical to repair. No photographs of the specific vehicle survive, though several similar improvised vehicles were photographed, and some images remain in Russian military archives. But the concept lived on. Soviet doctrine evolved to recognize that different tactical situations required different vehicle characteristics. The idea that heavily armored, slow vehicles had value in specific roles influenced post-war heavy tank development. The acceptance of crude improvisation when sophisticated solutions were unavailable became part of Soviet military culture. Modern military historians studying Sokolov's improvised vehicle identify several factors that enabled its success beyond the obvious armor thickness. First, the agricultural tractor base provided reliability that military vehicles often lacked. Farm equipment was designed for harsh conditions with minimal maintenance, characteristics advantageous in combat. Second, the crude construction actually provided advantages. Mismatched armor plates at various angles created complex deflection geometry that made penetration difficult. Sophisticated tanks had uniform armor at calculated angles. Sokolov's vehicle had random angles that happened to work effectively through accident, as much as design. Third, the slow speed forced careful tactical employment. Fast tanks encouraged aggressive tactics that exposed them to defensive fire. Slow vehicles required more deliberate approaches that often proved more survivable. The limitation became advantage through forcing tactical discipline. Fourth, the simple mechanical systems had fewer failure points. Sophisticated tanks had complex mechanisms that broke regularly. Sokolov's vehicle had tractor engine, truck transmission, and agricultural hydraulics, all designed for reliability over performance. This simplicity translated to survivability. Fifth, crew psychology mattered. Sokolov and his crews knew they were in crude vehicle. They couldn't rely on speed or sophistication to save them. This forced heightened caution and better tactical judgment. Ironically, feeling vulnerable made them safer through promoting careful tactics. The specific July 1944 engagement that destroyed 4 Panzers has been analyzed by military historians as case study in the value of specialized vehicles for specific missions. The tactical situation, assault against prepared positions across open ground, heavily favored defense. Conventional Soviet tactics, sending fast tanks in mass attacks, had failed repeatedly. Sokolov's approach, using heavily armored slow vehicle that could absorb damage while crossing the killing zone, succeeded because it was designed for that specific tactical problem. The vehicle wouldn't have worked in mobile warfare, it wouldn't have worked in pursuit operations. But for frontal assault against prepared positions, it was nearly ideal. Modern armies recognize this principle. Purpose-built vehicles for specific missions often outperform general-purpose platforms. Mine-resistant, ambush-protected vehicles in Iraq and Afghanistan represented similar philosophy. heavy armor and specialized design for a specific threat environment, accepting reduced performance in other areas. Dmitry Sokolov died in 1981 at age 66 in his hometown near Tula. His obituary mentioned his military service and decorations, including Order of the Red Banner, but focused on his post-war work in agricultural machinery and his family. Local veterans organization provided military honors at his funeral. Among his papers, family discovered detailed drawings of the improvised vehicle's construction created from memory in the 1970s for historical preservation. These drawings, donated to Russian Military Museum, provide most comprehensive documentation of the vehicle's design and construction methodology. The drawings reveal sophistication that descriptions didn't capture. The armor placement followed careful calculations accounting for likely impact angles. The internal compartmentalization separated crew, ammunition, and fuel in ways that maximized survivability. The mounting systems for the gun used principles that wouldn't be formalized in military engineering texts for decades. What appeared crude in execution was actually sophisticated in concept. Sokolov had designed vehicle using practical engineering that formal military designers would have rejected as too simple. But the simple design worked better than complex alternatives in specific tactical situations. The 4 Panzers destroyed in July 1944 are documented in both Soviet and German records. Soviet after-action reports identified the vehicles as Panzer IVs from German armored unit defending Rzhev sector. German records note loss of 4 tanks to unusual Soviet heavy armored vehicle, possibly experimental type, on July 27, 1944. The German assessment that Sokolov's improvised vehicle was experimental type reflects how unconventional appearance created uncertainty. German intelligence spent resources trying to identify this new Soviet tank type that didn't exist. The psychological impact of facing weapon you can't identify or categorize exceeded the tactical impact of 4 destroyed tanks. The legacy of Dmitry's coffin extends into modern military thinking about improvised and specialized vehicles. Modern forces facing asymmetric threats regularly improvise protective modifications to standard vehicles. The principle that Sokolov demonstrated, that purpose-specific design outperforms general purpose in certain situations, guides development of specialized military vehicles worldwide. The cost analysis remains striking. Sokolov's vehicle was constructed from salvaged materials with minimal new procurement costs. Estimates suggest total material cost, if materials had been purchased rather than salvaged, would have been approximately 2,000 rubles in wartime currency. A factory-built T-34 cost approximately 130,000 rubles. The improvised vehicle cost less than 2% of conventional tank, while achieving tactical success in specific mission profile. The return on investment, measured in destroyed enemy vehicles and completed missions, exceeded conventional armor by wide margins. 4 Panzers destroyed at cost of crude vehicle built from scrap represented exchange ratio that sophisticated procurement couldn't match. The cheapest solution achieved better results than expensive alternatives. In final assessment, Dmitry Sokolov's homemade tank represents triumph of practical problem-solving over doctrinal rigidity. While military theorists dismissed improvised vehicles as crude and ineffective, a tractor mechanic proved that sometimes crude and effective beats sophisticated and destroyed. The mockery that initially greeted his work transformed into legend as the vehicle achieved what conventional armor couldn't. The 4 Panzers destroyed in 19 minutes during July 1944 engagement stand as permanent record. Against all predictions, against conventional wisdom, against mockery from superiors and peers, the improvised vehicle succeeded where purpose-built military equipment failed. The success came not from sophisticated engineering, but from understanding the specific tactical problem and designing specific solution. Modern militaries spend billions developing multi-role platforms intended to handle any situation. Sokolov spent nothing and created single-purpose platform that handled one situation perfectly. The lesson should be clear. Sometimes the best solution isn't the most versatile one. Sometimes it's the one designed exactly for the problem at hand, even if that design appears ridiculous to those who don't understand the problem. The homemade tank sat in Sokolov's maintenance yard for 3 weeks before combat employment, accumulating mockery and predictions of failure. Then it destroyed 4 Panzers in 19 minutes and forced German tactical withdrawal. The mockery transformed into respect, the predictions of failure into documentation of success. The crude appearance remained, but appearance never mattered. Function mattered. Results mattered. Survival mattered. Dmitry Sokolov built a tank from scrap and was mocked for it. Then he proved that sometimes scrap welded with ingenuity outperforms sophistication, built with arrogance. The 4 destroyed Panzers vindicated his approach. The crew casualties reminded him of the cost. The tactical success validated the principle that sometimes the best weapon is the one nobody else thought to build. That's the complete story of the homemade tank that was mocked until it crushed 4 Panzers in battle. Not through elegant engineering, not through sophisticated systems, not through following doctrine, but through understanding that survival comes from protecting what matters and accepting that crude execution beats sophisticated failure every time. The tractor mechanic who built impossible weapon taught lesson that remains relevant wherever conventional thinking fails and desperate innovation succeeds.